Okay, I'm here with Ryan to talk about this thing that we had a tweet interaction about. Ryan, what's the thing?
So basically, I think the original comment was something like command palettes, which are a really popular UI feature in a lot of different programs. My tweet was basically like, these should just be a first class thing at the operating system level. Like at the platform should decide what it means to have a command palette. And individual applications, so the things authored in a sort of decentralized way, should click into the centralized mechanism of a command palette, rather than when you have each application having the responsibility of implementing its own command palette. Some programs just don't do it. Some programs do it differently than others. As a result, like modern computers feel this is like a microcosm of a larger issue, which is that the UI in all these different programs, because everyone is implementing things in different ways, everything feels different, everything acts different, nothing composes in the way that you would really want it to, because nobody's using a consistent fundamental mechanism for UI in general. But in this case, I was referring specifically to command palettes. So command palettes, I guess for anyone who doesn't know, it's basically like you know, if you use really old programs, or if you took a computer class in school or whatever, I don't know what they're like these days, but when I took a computer class in school, you're like, oh, like go to the file menu and you can click the file menu, click open, and you can open a file from disk, and then you click save, you file save, and then if you want to look at some editing options for the file in whatever program you happen to be using, you can go to the edit menu, and the edit menu has a bunch of things you can use to edit. So it's sort of like hierarchically categorized in terms of what the program supports. A command palette sort of reverses that, where it says there's going to be one list of everything, and you're going to hit a quick keyboard combination, or there's a button in the UI or something to pop up this palette, and it's just a list of literally everything. So it's not hierarchically organized at all. And what you do as the user is there's just a fuzzy search. So you type in a string, and it filters through the names, descriptions, maybe some search tags, so basically like hidden strings that are maybe synonyms for things that are inside of the giant list. And basically it's just like, as the user I find both models to be pretty reasonable. Like I like the idea of hierarchical organization, but I don't like that being the primary means of organization for a program. So a lot of times, like if I don't know exactly what I'm looking for, I don't know how someone else would have hierarchically organized it. I'm just trying to discover things. I'm trying to search for something, maybe a specific operation that I know exists, but it's like, how does someone else classify it? I don't know. Like it could be classified in many different ways. And I guess that's one of the problems with like having one hierarchical organization for the whole thing. Really, you can hierarchically organize operations in a program, for example, in like 100 different ways. So having just one can sometimes be a worse sort of experience for the user. So point being, very popular paradigm these days. I think a lot of people first saw it in Sublime. Blender has had something similar for a while. File Pilot now has it.
Well,
I have it in the RAD debugger.
My most recent experience with this has been, I'm a Focus editor user. So Focus, of course, does everything this way. But then,
right.
because I've been doing Rust programming for reasons, you kind of have to LSP, which normally is not useful to me, becomes very, very, very useful. And so, I use Visual Studio Code with the plugins, and my computer becomes a jet plane and starts to take off, right? But so I'm in Visual Studio Code, right? And it's actually the same bind to open the command palette as in Focus, and I was able to find many things easily, like, oh, I need to attach to a running process. Like, oh, attach. Oh, that's a thing that exists. Okay, let me use that. Then it doesn't work well, but that's like not the command part. That's just VS Code being bad.
Right. Yeah. I mean, that's a really good example too, because in some programs it's a breeze to use, and in other programs it's like, oh, it's a little bit janky. Like it's the command palette's sometimes very slow for no good reason. It really hinders its usability in general when it becomes like unnecessarily difficult. Like it requires a lot of mouse clicks to get to the thing, or if the search is like, I don't think that happens in VS Code, but I mean, like if you imagine, I think in Visual Studio, like the actual Visual Studio, I don't think they have a command palette. Maybe they do these days, but it's like my understanding is like there was a mechanism to search through everything. Like there is a search you can do, but it's like this. It's much more legacy style. Like open this window, and here's all the categories that you can search through, and then you type a string, you hit enter, you wait 5 seconds, and then it pops up. It's like it feels like a Google search kind of thing. Whereas a command palette is like it's very distinctly different because it updates on every key press. It's basically instantaneous in most cases, and I feel like it's a lot of subtle difference, but it's it's a very different experience than like those traditional search. Like,
do you also use Windows this way? Because the way I use any Linux or Windows system is I hit Windows key and I type something and I hit enter, and I do not do any other thing basically most of the time.
Yeah, I mean that's how I would like to use Windows, but the start menu. See, the start menu feels like it should be this, right? But it's so bad. It's so much worse than it should be. It feels like the start menu sort of began as like it kind of began as this.
It began as the hierarchical. No, but even I think Windows XP. Like I remember using the Windows XP hierarchical version, right, to launch programs.
Yeah, but then like eventually they added like the search feature where it's like Windows key and you just type.
Yeah.
And it's like halfway to a generalized system command palette, but it's also not because it doesn't click into any of the options within the individual programs or anything. It's like just to find files and programs.
Okay. So that gets to the meat of it, right? Because I was originally confused because I'm like, okay, what does it mean for the entry point of programs to not be the normal entry point? So that was a bit confusing, and then it sounded like just a second ago what you were advocating was actually just, this is a straw man, but like the Mac OS, everybody uses the Objective-C dev kit that we give you, therefore everybody has the same command palette and it feels the same. But it sounds like you're actually saying no, you want to hit Windows start and do something in a particular program.
Yeah, like I think basically it's kind of hard to know the exact shape of what like I personally would implement, because there's something about like there's like a fundamental difference between, for example, an opt-in library versus something like a feature of the platform. Like those are two very different, and I think it just has to do with control flow, like who controls the control flow. If it's a feature of the platform calls into you. And if it's an opt-in library, you call into the library. And if it's like a UI library that is distributed with the operating system, you call into the UI library. But if it's a feature of the platform, it's like it's like exactly reverse. Like you are called in some context and you return information that is used for some other purpose that you have no control over. And I think what I'm saying is like instead, like on Mac OS, I don't program for macOS, so I don't know exactly the picture. But my impression is that like they have really rigorous, like relatively rigorous, like certification and all these things, and they expect applications to call the libraries in a particular way. I would assume it's like that. And the feeling that I got more, and this came from working on the debugger, because the debugger has a mini version of this problem. The feeling that I started getting was like, UI paradigms like the command palette should really be a platform feature. So they should fall out of the platform calling into the application, not the other way around, not the application calling into the platform. And so I had to implement something like that in the debugger because there's tons of different like various UIs and each like visualizers and things like that. And each visualizer could define a set of commands, operations, settings. Like it can define all sorts of things that are very particular to the visualizer. But each visualizer does not want to define a command palette, for example. Like it's just like, how many UIs are you going to have to implement for this whole thing? Really what you want is the individual visualizers, which are analogous to programs in the platform analogy. You want them to be able to express options and concepts that you'd like to show up in the palette, but you don't want them to have to ever be doing something like draw button or like do button or whatever. Like you don't want them to even be a part of that part of the problem. That should be well defined at the platform before the visualizer is even in the picture at all. So, so then it's like, okay, well, where do these options come from exactly? And it really becomes more like an API, like in a sense, a kind of API description. Like it's a description about what kind of information the program or the visualizer accepts. But like once the platform has enough information about the potential, how exactly it's sketched out, is it entry points, is it certain kinds of command buffer structures, is it things you could write into a ring buffer? Who knows all those details? There's probably a lot of ways it could actually shape up. But I was just thinking like, whatever that information is that needs to be expressed by the program, let the program express it, and then let the platform implement something like the generalized command palette for all of it. And that way, every program you ever open, every program that's ever executing, gets the command palette for free, because they didn't even have to think about it. It's just a part of it. I think, and this gets at something really interesting about like terminals versus UIs.
Mm-hmm.
One of the reasons why people like terminals so much, I think, like, there's this whole war, like UIs versus terminals.
Mm-hmm.
One of the reasons why people like terminals so much is because they have this feature for really, really simplified input and output. It's all like textual output, just simple data pipes in and out, and things are built to sort of click together in this sort of like text in, text out kind of way. I think you could just do the same thing with UI paradigm stuff too, and it would work perfectly well. And then it wouldn't be like this. It wouldn't be the modern picture where we just punt. Like it's like, okay, we're calling the program and just hope they implement a reasonable UI. It's like, no, like we call the program and the program's defining whatever was useful for the program to define. But we've solved the UI problem at a lower level, basically. And by a lower level, I mean shallower in the call stack, if you will. Like we've solved UI, and our UI layer is calling into the program rather than us calling into a program expecting it to call into our UI code, basically. So it is. That's what the tweet was about,
Right?
And it just came to me from working on the debugger and being like, not every visualizer implements a command palette. The debugger implements the command palette. So I'm saying like similar to that, you could just have the platform define a command palette for programs, just like the debugger did for visualizers, if that makes sense.
Right. Would you do that? So one thing that comes to mind is like namespace collision, I guess. This is just the UX of it, right? Do you have?
Yeah.
Do I have? And there's also a keybind difference potentially. Is there still a difference in this world between I hit Windows key and I type some stuff and it goes to my global launch programs menu, versus I hit some other standardized keybind on the window and my currently focused window has a command palette pop up?
I think basically they would be differently filtered versions of the same UI. So this actually happens in the debugger as well. Like if you hit F1, so F1 is the key that I have. I also have Control-Shift-P for like familiarity for F1 and Control-Shift-P are both familiarity keybinds. Like Control-Shift-P is Sublime, F1 is like traditional F1 help menu kind of thing. And in the debugger, it's contextual. So if you are focused in a particular panel, you hit F1, it's like, okay, you're zoomed into this context, you're in a source viewer, you're in a memory viewer, whatever. Let's filter the entire lister based on your context. Now, if you hit F1, it pulls almost everything in. But then, for example, if I wanted something like, if I right click on a source line of code, so I'm like in the source viewer and I'm like, oh, I want to run to this line. So I right click on some source line. That is a much more filtered version of that same exact lister. So it's basically like, oh, right click. It's like, I'm generating the entire generic lister thing, but it's filtered down. It's scoped down in a way where it's like, oh, I'm looking at textual commands. Like it has all these things that you can apply as filters, basically. And so similar to that, I think it would, maybe it would be a single keybind in both contexts. But then it's wherever you happen to be focused or whatever happens to be your focus, that is used to generate the content. That contextual information is used to generate the list contents. So
yeah, I feel like there's a big difference though in that So when you are developing the debugger, you can ensure that there aren't significant collisions, right? And as soon as something becomes a platform API, you're in a very adversarial environment.
Yeah. I mean, I don't think the collision thing is a problem exactly. Like you namespace by the program name. It doesn't even have to be a namespace, quote unquote, but it's just like the lister, the UI would look like, oh, here's an option. Like it's like, oh, move left. Or that's a bad example because that could actually be something like that could be defined by the platform, but it would be something like, I don't know. What's a good example? Like, okay, disassembly view. Let's say you have a disassembly program viewer instead of a visualizer. Since debugger examples are in my head, but you have a disassembler program, and one of its options is like enable or disable code byte visualization on a per line basis or something like that. You would just have in the menu, it'd be like, oh, disasm.exe or whatever you want to call it, as a little bubble prefix thing, and it's like, oh, this is an option for that program. If someone else defined it, you would have as the platform, you would know who's registering it, so you know how to qualify it basically.
Do you okay? If I have two versions of the disassembly program open, does the toggle switch apply to both, and do they then have shared state between the two?
That's an interesting question. Probably what you could do is,
because in the debugger, presumably you just have the same config bool for both. If you have two disassembly views, you can
actually there's so everything works on a generalized like config tree system. And so if you're within a tab, all of the settings you look up, like basically the pattern for looking up what a setting is like a single toggle option is it scans up the tree based on your context. So if you're within one tab, that tab is one node in the tree, and it's like, oh, I'm going to look at my node for any enable code bytes flags. Yeah, like basically I'm going to look here, and then if I don't find it here, I'll traverse up to my parent, traverse up to my parent, traverse up to my parent. And if I don't find anything, then I fall back to the schema, basically, like the schema which says, here's what it means to be a disassembly tab. Here's the things that can show up in my node, and here's the defaults if you don't have them, basically. That's just a piece of data I have. And this is the kind of thing that you would just register as a program. You just say like, here's my API. There's another aspect to this also, which is that I don't actually think programs, I think it makes sense to reevaluate what an entry point is, like as a concept. I'm not sure it makes, or I think, so something interesting about like the visualizers in the debugger is that a visualizer is called not just once. It's not like an entry point that you spawn a thread for or something. It's called repeatedly, and it has a way to get back to state that it has across multiple frames, but it's called repeatedly. It's like, I'm calling the visualizer, and in the visualizer, it has the opportunity to do some work to produce UI for a frame, but it's called over and over and over again. And that difference, that sounds like a tangent. I don't remember where it was even going with that. But basically, it's like changing the entry point. Changing the entry point could have some fruits, basically, because that's how that seemed like the natural way for me to define it in the debugger. So I think a similar thing could happen at the platform layer.
Well, so isn't that, I've been thinking a lot about, most platforms do some variant of an event loop thing, which I feel like is trying to do this thing-ish, which is like, I have a serial interaction with you, the program, but that has to happen through message passing because we're in a distributed system situation now.
Right.
But yeah, it's like not ideal though. I wonder how much of these things, like you mentioned the UI being not favored compared to CLI. I kind of think that, or it's hard to evaluate that, given that the mud you have to swim through on the UI side. Like I've been doing UI today, and yesterday for this, one of these Rust things I'm working on. And so the goal was like, hey, I actually care about what the result looks like now. So I would like to, and also I'm kind of interested in software rendering. So I want to do a software renderer where I, okay, just give me like a cross-platform thing so I can get the event loop and get a window and submit pixels to the thing. That's already, there's like a bunch of code running beneath me to do that on every platform. And then there are issues with VSync and with frame pacing, and on Wayland I have to do a special thing because like I was able to like get my window manager to like lag or hang up just by when responding to the Wayland wants to be very like you get called to render through the message loop and then you like respond like this. And then you have to like request redraws to actually render at the frame rate, because like by default it's like you render when you get interacted with. Was at least the setup on this with this lib I was using. So then it's like, I draw and then I request a new render at the end. Except doing that like froze my entire computer UX experience, right? Which shouldn't really be possible, I think. But somehow,
right.
And so then the library has like on Wayland, please call this thing, which is like pre-submit, which is let us, the library, know when you are about to submit a frame to the window manager on Wayland, because we need to throttle redraw events and like call things.
Okay.
It was really bad.
What a nightmare. Oh my gosh.
So I wonder like maybe the current event loop thing is fine if the event loop was good.
I think so. Yeah, I think so. Actually, I don't have a problem with the event loop. I'm not sure, like, I don't have a problem exactly with the event loop, but I think that there's something useful that, and maybe this isn't completely true. Maybe this part's a red herring, because maybe this is just the way that it turns out when you write it within a program. To me, it seemed like something useful came from the fact that a program has to be aware that it's being called multiple times. So instead of a program being a single entry point where it runs once, if you want repeated runs to, for example, like, and this leads to some undesirable things too, like if you call a command line application to parse a file and then like dump some output from it or something like that. But then this, you call this program once, it takes the file as input, and then it spits out the filtered output or whatever. And then if you call it multiple times, and basically you're calling it multiple times on the same file, but passing it different filters, because you're like, I want to see this, and I want to see that, and dump it out to 3 files or something. It's reparsing the file every time. So it's like this weird, like, why something's wrong about the way that programs are sort of composing at that layer, because it's like, why is it doing all this duplicate work when it could be a kind of situation where it's like, no, I call into this program and that's like one heartbeat of the program, where the program is like, okay, like they're asking me to parse this file, let me check my cache, check all this stuff, okay, pull it into the cache. Next time you call the program, it's in the cache still, so just requeries and it gets there. But okay,
well,
go ahead.
Okay. If you extrapolate that direction, don't you, like, I understand the feeling, but it feels like this is the same feeling that leads to something like Urbit, and Urbit might not be the best incarnation of the thing, but right, the Urbit model is like, hey, we should be programming in like space age fairy dust functional programming land, and my program should not even have to worry about being turned off ever. Like I should just be able to write a program and it launches, and there's no memory, there's no like the hard disk, right? It's just I write code and the code is like forever executing, right? But what's weird to me about that is it seems like how do you develop something that never like relaunches? Because to me, I feel like the tremendous advantage of the programs get restarted the whole time means that I can change the code and relaunch it, right? And say in
Mhm.
I write a CLI program that reads a file and then I
Mhm.
relaunch it, that's very deterministic and there's almost no state leakage between the two runs, right?
Yeah. Yeah, I mean that's true. I think that the mechanisms for sharing like like things that could be defined as like a pure functional artifact of like some deterministic function
I guess
that
the
you
point
want
is
to
that
treat as
the
deterministic.
CLI program is implicitly a pure function, kind of.
Uh,
Like you launch, you read some files, you write some
yeah,
files, you exit, right? Only
right.
the files in and out are like,
It's a
the thing.
it's a pure functional program with like no caching. It's a pure functional program without, when you actually write this sort of like, I don't even think about it as functional because I'm not like an FP
Yeah.
bro, but I write UI code this way where it's like this thing's being called all the time. It's immediate mode, so you can close the tab whenever you want. There's not like a destructor that has to run to clean up these resources or something. It's like it's just pulling things into a cache, and they're basically like pure functionally derived from like the inputs basically.
Yeah.
When I'm in that situation, like um yeah, so when I'm writing that kind of code, it's totally true that I could just be recomputing it every single time, and that's how I started actually often. Is like if I'm like writing some like the bitmap visualizer or whatever, and I need to pull down some data, upload it as a texture to the GPU, and then draw with the texture. The first version of that feature I did literally did that. It was like, oh, read the data, put it into a texture, draw the texture, throw the texture away. And I did that every single frame. But then obviously, like the first upgrade you make to that is like have the inputs changed. If not, then have a cache where I have the texture and then these textures get thrown away or like that kind of thing. And so to me, it's a flaw in the architecture that this sort of caching mechanism isn't there. Like there's no way within the traditional way that CLI programs compose. There's nothing in there that actually enables this caching in a reasonable, like it's not sketched out in the architecture, I guess is what I'm saying. Because each program could do it, but in practice nobody does.
I'm interested in this, but just to add to your point, I wonder how related this is. Today, for this renderer I wrote, it's a CPU renderer, and one of the cool things is, I'm doing yet another iteration on the hash. You do tile-based hash rendering, where the program has like a set of you do a command queue for draw stuff, and then you run them. You go wide of the tiles and you compute a hash of like what is happening to this tile, and if the same thing is happening, then you could say, hey, what's the pixels already in this tile will suffice. They're the same, so I will just not do the drawing operation. Yeah. But I wonder, okay, so what is it you feel should could be cached in the CLI program case? Because that's interesting.
Yeah,
it's a
this is a
novel
little
thought.
bit. Yeah, it's a tangent from the UI part, but it is like tangentially related. But so it's really it's anything that you think should be deterministic. So a good example of this would be like so the way that you would write procedural code to like take an input file and parse it, you'd be like, okay, open a file handle, out like you have some idea, like I don't know, open a file handle, you allocate a buffer to parse, to read the parsed representation of whatever it is you're grabbing from the file, allocate a buffer, open the file handle, read, unpack, do whatever you need to do, and then you store it in this loose decompressed representation basically in the file buffer. Parsing a file is a good example because it's like it should be strictly deterministic, where it's like the contents in the file, you could hash that. Like if you have a cryptographic hash of the contents of the file, you could have a cache that's like this hash maps to this parse always.
But you have to key the hash by the code that is doing the transformation, kind of.
You do.
You change it.
That's a good point.
Yeah.
Yeah. No. That's a good point. I think and that could just like if a mechanism like this were defined at the platform layer, it probably would key the hash. It would key this cache based on what code is running here.
Yeah.
But I think once you have that, then you have like, oh, then these programs do compose in a way that's not losing something because there's no caching at this layer. There's a pretty strong performance incentive to zoom into one program and be like, no, this is going to be a server, and it's going to be serving requests, and that server will be doing the caching in this way. You know what I mean? So it's sort of it takes something away from the composability that you get out of the CLI. But yeah, I think this is tangential to the UI part. It is interesting. So I don't know what you want to talk about, but that is interesting.
Well, it feels like another thing that maybe the Urbit people can do, because I'm pretty sure.
Right.
But again, it's like I say the Urbit people can do this thing, but obviously it's like kind of lame and slow, so I don't want to use it, right? Like, but I'm pretty sure they can do things like, exactly identify what algorithm it is that is running on a piece of code. And because it's so functional, I think they can do, like, they could automatically in the interpreter have a thing, I'm pretty sure, to say like, oh, this data is about to pass through this transformation, but I already saw this happen before, and I have a cached version, which I'm just going to pull in.
Yep.
Yeah.
But yeah, so I think on the UI, because I was trying to 10 minutes ago or something, I was trying to loop back to a UI point on the entry point thing. And I should say that before we move on to something else. And basically the only point that I was trying to get to is that the operating system currently, for any program, it has a really, like, if you think about like schema as the thing here, the operating system has like a trivial schema for any program. And the schema, which schema is just another way of saying like type info, basically. So the type info of the program, it's like the inputs are it's like a single function. You call the function. This function takes in a command line string or list of arguments or whatever. It takes in a standard input and it returns standard output and standard error. And that is the schema. So importantly, like, that's not all programs do, right? So programs can open a window, they can start drawing graphics, they can build UIs, they can do all sorts of things, write audio to your speakers or whatever. But that's the schema that the operating system actually knows about. So that is like missing so much information from the operating system's perspective about like how would you generate a command palette or something like that for any of this. It's like, well, who knows? Like, you just have to bank on the fact that you have some like, or a good example of this would be like you're in a terminal, you're running a terminal, and you want to autocomplete all the possible options for any given thing. How do you just have to hope that, I don't know, you have some bank.
Well, the way they do that is like, if you use Z shell or something, you'll have like a huge bag of extensions that knows about every command under the sun. Or we'll do things like, oh, this is a Git thing, so I'm like launching Git commands in the background to find things out about the repo to give you autocomplete.
Yep. But yeah, so to me, in my head, I'm like, this should flow out of the program as it's written naturally. Like, it shouldn't be a thing where somebody has to go maintain this separate extension for a random shell. It's like, this should just be a part of the program. Like, you should just know, the program should say, here I am, I'm reading this particular key from my input, whatever, which could mean anything. That could be a setting, that could be the disassembly, like code byte setting, that could be a lot of different things, but it's like, I'm reading this key, and it should simultaneously be expressing to the platform, by the way, here's a key I look for, and it's got this type info, and this is what it means, and here, by the way, here's a display string for it, here's a description string for it, here's all the things. And really, like, you could just express that in one place, in a single place in source code. Like, you say, grab me the option.
Well, you could imagine, so in this Git case, the weird thing about the Git case is, okay, so I have this shell, right? Like, if it were a GUI program, you would just type things into the GUI program and it could autocomplete it doesn't have to be a fancy thing, but you have this disconnect of, okay, I'm typing into a program that is not Git to then take that string and like one shot enter it into Git and have Git do something and then exit. But okay, how program interop is a different experience I had today, which is okay. I went and got a sampling profiler from a classic Linux moment. I went to somebody's GitHub and I copied a command and I pasted it into my terminal, and it installed software on my machine from the web by go to the server, pull the script, and pipe it into sh.
Nice. Okay.
Yeah, which you do a lot. But okay, the software works. But obviously you don't want, in this case, they don't want to, the person who made this did not want to re-implement like having a visualizer for profiling info. So what they do is they piggyback on Firefox or like the browsers who have support for this. And the crazy way it works, the UX was really slick, is I ran it. So you do like, I think it might be like samply run or something, I don't know. And then the command, and it like launches a subshell, does the sampling profiling. When the program exits, it then has produced a compressed JSON file or something that it like saved as a file, and then launches itself as a web server on localhost to serve the file. And then does like uses the link opening API to say like, hey, open this thing, and then like I fly over to my browser and there's the profile trace.
Yeah, I mean,
right. And then you do close tab and you come back and you have to like Control C out of the thing, and then I have to delete the file. But is that the kind of UX flow that you would like to do in a less janky way that involved like a TCP socket and a URI handler?
Yeah, I think so. I think yes, like in a sense, where basically like the thing that feels frustrating about modern like PCs today is that, well, this is true on pretty much all computers, but like including phones and tablets and everything. But it's like, if I spend all this time writing a really good profile timeline visualizer, like you could describe that with type info, and it would be like, look, this is a profile visualizer that takes this particular file format as input. It's like the Chrome tracing JSON, whatever. Or it's like, maybe like if a new platform is coming and defining this stuff, maybe they could just like define a better way to have structured binary data so that it's not, people aren't just passing JSON blobs everywhere, but because that's an enormous amount of overhead too. But let's just describe this profile visualizer as type info, where it's like takes this profile data input, produces UI as output. The fact that is coupled to like completely orthogonal parts of the problem is pretty unfortunate, where it's like, because of the library I happen to be using for instrumented profiling or something, or sampled profiling or something, they write to their own format, they have their own visualizer, and I can't use this other visualizer that someone wrote. Now, obviously, there has to be some level of like interop and standardization of like the data format protocol, and I don't think you can really get around that in some sense. But I think there's enough drawbacks to the base layer that make that just not worth it for people. And it's because things are so janky. It's like you have to jump through like really strange hoops to actually get interop that feels good. Like having to delete the file is an example of like what is like I have to like garbage collect my file system now whenever I want to use programs that click together. It's like what is that? And so I had this experience before, because this is like the example I always go back to. I built like these graphing calculator things in 4Coder. They were like really, it was a cool demo, but it was like garbage graphing calculator. Like you type a little equation in your code editor, you get a little graphing thing. But the thing is, like, if you imagine this as like a coordinate space, like of programs, I was sort of like going, like, forcoder had gone in this axis towards like text editor, and then there was this separate axis of like Desmos graphic calculator kind of thing.
Uh-huh.
And because I wanted both to be in the same like window and have them live update to each other's like live update to the data, or like I wanted the graphic calculator to live update to data in the editor and that kind of thing. I had to build this like weird point in the middle where I took forcoder and made it a little bit more like a graphing calculator. But I would have to put in way more work to actually get it to the quality of like a Desmos style thing.
Mm-hmm.
So it just ends up in this like middle state where it's like, yeah, it's forcoder and it has this crappy little graphing calculator extension thing, which is like barely useful in some cases. And it's like, it would be better if someone who wanted to build a really good graphing calculator interface could build it without knowing about what I wanted to do. And somebody else is building a code editor interface without knowing about the graphing calculator people. And then at the base layer, you would have ways for these things to naturally start. Like the platform would define the ways in which these things would naturally start clicking into each other. So going back to your question, yes, basically like that kind of flow where it's like you've got this sample profiling thing which takes care of the actual sampling. That's an orthogonal part of the problem to the visualizer part. And if someone has implemented a visualizer for this format, those two things should be able to click together. So yeah, I think that should just work. But so
I guess the way
yeah.
I would think about that is one danger I think with OS design or platform design is as soon as like all previous attempts essentially to I don't want to say define this sort of thing, but to like be prescriptive about how programs shall interact with their environment have all catastrophically failed, right?
Right.
But that could be because the people doing it didn't know what they were doing. That, you know, maybe we just have to try more times. But there's like the things that, at least to my recollection, the things that have turned out to be really, really good are when you build kind of, I want to say, opaque mechanisms where you pass like binary data. You basically have like, what things that work really well to my knowledge are like, there's an opaque way for you to pass data, and then the two sides can like have agreed upon what the format for that data is, and then additionally you have some just simple identifier for like what is the data in between. So one of those would be like, I output a file that has the file extension PDF. Okay, so we've got like the mechanism to transmit the bytes in a blob, and then we have the .pdf, which like is some kind of coordinating mechanism for what is the thing. And trying to have like, and the nice thing about that is it's simple. It's actually just labeling, right? So I don't have to go into the complexities of like what a PDF is. And the platform doesn't need to know about the platform can be completely oblivious to what a PDF is, but it can do this like mapping to like, other people have registered themselves as PDF handlers, and so they can open this file, and that seems to work really, really well, mostly. And it's still a bit janky, but maybe I feel like the things that could be, to me, obviously fruitful are like when they have this quality. So another version of this, which I have for Serenum, is like you want to be able to. There's this thing that like these interprocess procedure calls, which are like, I kind of want to just do syscalls into my parent process. And the way you do that is you say like, hey, I want to do the syscall thing, and you just provide a string that's kind of long and detailed. And then your parent will have registered like, I support this window manager protocol. and then the child can say, I want to talk to somebody who supports this window manager protocol, and you walk up the tree, and the first person you hit who supports this, you like get a handle to. And now you can do things, and that's mostly to establish, we have shared memory and can do high-speed communication. But there you just have this like discovery, and the discovery is through a string, it's through a label that both sides. So then the kernel can be like completely oblivious to what is happening, and so you can rev these two. You can like upgrade them. You can say like window manager now supports API v1 and API v2. As a program, I query for v2 first. If I don't have that, I fall back to v1, etc.
Right? Yeah. Another thing. So another interesting thing about this too is like, when I was thinking about this problem before, it seemed like this is kind of going back to the entry point thing, but it's like kind of like there is a problem between. Okay, so there's multiple things coming up in my head. There's one problem, which is that anytime the user wants two programs to start communicating with each other, generally requires some kind of like manual intervention beyond just the user expressing that they would like to use this program in whatever context they're in. So if I want to like, let's say I do have a graphing calculator program, and I do have a text editor with an equation, and I want to view that in the graphing calculator. The steps I have to do are open up the graphing calculator program, copy and paste the equation, or copy the equation from the editor, switch to the graphing calculator, paste it, and then hopefully not like fix up the syntax or whatever, but like, and then if I and then let's say I'm like, maybe I can add notes to the graph or something. I'm like adding all this state or something, and then I'm like, okay, I'm good viewing this program. Close the program, go back to the editor, scroll down to a different equation, and I'm like, oh, I really need to open this up. I really need to look at this with the graphing calculator again. Copy and paste, open the graphing calculator, paste it. Like you have to go through this manual. The user is actively involved in managing the lifetime of things where it's like, I don't know if they necessarily would want to be involved with that. Like in all cases, in some cases, of course, yes, it's like you open a window to do some editing. You want to keep it there. That's user managed lifetime. But I also kind of want a way, like it feels like the platform should provide a mechanism, and this goes into the being called repeatedly type thing. It feels like there should be a mechanism for like immediate mode style operation from a program where it's like, I'm in my editor and I have blank space on the right side, and I have determined that this thing is an equation, and I could be rendering it. And maybe the user has even said that they want it to be rendering in some kind of way in the editor. If that is a mechanism that's like well defined from the platform's perspective, instead of just calling the graphing calculator, like boot up the graphing calculator, if instead it's like render this graphing calculator, like update graphing calculator with this as your input, then it's a very different thing, because then the operating system could just say like, oh, like I've got a little patch here inside of this program. I've determined that this is a suitable program that kind of clicks into place here. Given that kind of protocol thing the version of this we have today is file types, and programs register themselves as that kind of file type viewer or whatever. And point being, if you tweak the definition or the idea of the entry point from being boot up until you exit, if you instead go, I'm going to call you every time I want you to operate with these inputs, then it's like, then you could just start doing that. If the user scrolls away, the user didn't have to close the program. The user didn't have to do anything. They scrolled away, and the program naturally was closed because the operating system is no longer calling that program to do anything.
Okay, but this sounds like you have like an application within an application almost.
Yeah, well, in this context, yes, that is the idea. Now, it wouldn't necessarily be truly within. Like, for instance, if you did have this like annotations, like, or another good example might be like you're in the editor and you reference some model file, like a 3D model file. You're working on a game and you're like, oh, like player model equals this or whatever.
Yeah.
and the editor just renders a preview to that, and it's like, well, what do I do with references of this type? Well, I can deduce that it's like a 3D geometry data. I have viewers for that. Let me pick the best match, basically, and I'm just going to start calling it repeatedly. Then the user, it doesn't have to be truly within the program. Like if the user clicks on that preview, it could just turn automatically into a fully fledged version of the editor. It doesn't have to be like a neutered version of the 3D model viewer. It could just be like, no, that's like the actual program, because it's only one. Basically, what this means is that the person who wrote the 3D model viewer just wrote a 3D model viewer in the most straightforward way possible.
Yeah.
And it clicks into everyone else for free unbeknownst to them.
I wonder if there's a version of this, just because to me the version of this that I maybe already use is on Linux programs that do reloading, like hot reloading. Okay. So I have I have one, like I do my invoices like this, and it's kind of dumb. The way I do my invoices is like the output invoice is a PDF, but then there's actually like a graph, there's a CLI program that is generating the PDF from a file. So run that in a loop while I edit the file, and then have it like rebuild the PDF. And when that works well, I have I'm editing the source input and I'm seeing the PDF. And sometimes it's good, sometimes it's bad. But you could imagine doing that in this scheme where you say like, look, so the very the very clunky version of the scheme is, okay, I'm going to launch, let's say it's like an image viewer or a model viewer. I'm going to launch the model viewer. I'm going to pretend to be a window manager. So I'm going to present the window manager interface. And so the model viewer thinks it's running in a window manager. It's just a window manager that happens to be like the other program. And then I'm like relaying the things up.
Yeah.
So there's like one layer of nesting going on.
Mm-hmm.
So that's probably a little bit clunky. And then you could imagine the hot reloading is like, I have to write to a file and have it like detect. And so we're round tripping through the file system API. Yeah. Which is an extra level of clunkiness. And then maybe you could like improve that by, we have an interface that is designed not maybe for window managers, but for this kind of embedding into a program. And that is, you can be aware that you're inside another program and that maybe you make different choices. And then maybe there's like a way to push data with shared memory instead of through a file.
Yeah, I think so. Another thing here is that I feel like,
but you want data to come back maybe up. You
could, yeah. You definitely could. That's definitely true. I think it has to do with that schema aspect, because going back to like the command palette thing, in order for a visualizer in the debugger, for example, but in order for any program in a platform that had its own command palette thing, in order for a program to inform the system about what command palette things are relevant for this program, in order to even in order to define that, you need something like I said, a schema or type info or something. Like, there has to be a way of the operating system knowing in a structured way, in a way that it's in an intermediate format that makes sense to everyone, basically, including the platform. There has to be a way for the platform basically to say, okay, here's a program. I know this is a program. I can somehow query information about this program, including what are the commands it accepts, what are the types of operations I can set. Again, it's like, are these entry points that it can that it can dynamically call, or are they probably I don't even like that, because I think callback. I think the sort of like heterogeneous callback things generally suck more than like, oh, I call the function, but I tweak the way I parameterize it. I think that tends to be a lot better. So maybe it's still one entry point. but it's like, oh, like I submit these, like, yeah, it's like a command buffer or an event loop kind of thing. And the command buffer like event loop is structured in a way that it's not currently in like existing, like on Windows, you don't have, in the Windows event loop, you don't have information like, oh, I got the message to like open a file. Like that's not a mess. That's not a message. No, I'm not saying it should be files. I'm not saying it should be opening them. I'm just saying like that's what I'm kind of talking about, is making that thing more structured and more relevant to the interests of the application. Because basically, like what inevitably ends up happening when you start with the Windows event loop, or Wayland or X11 or whatever, is you have the X11 or the Windows event loop, and you immediately have to translate them into an event loop that actually makes any sense to your application. So the classic example is like key bindings. In a game, I've got some data structure that maybe the user can edit if I want rebindable controls or whatever. But it's basically like, oh, WASD, that maps to move up, move down, move left, and move right. And so I have this completely different command buffer structure. So first I started with the Windows one, and then I have a command buffer thing, my own command buffer message loop thing, where it's like higher level, where it's not key press events anymore.
Yeah.
It's like control press or control down or control
it's like
a
user action stream or something.
Yeah, right. Yeah, so it's like, so basically, like, to me, it seems that because the platform is stopping short, the applications just have to implement more as a result. So that's another good example of like, yeah, the platform probably should be doing things like defining key bindings in one spot, and just like it should know all the key bindings for all operations in all programs, and that should be in the command palette actually. And the command palette should just allow remapping that in a standardized OS level way. And when you write a program, you literally, like, you just say if move up, if move up command, then begin moving up, or move up press or whatever. And you should just write that as the program, and whatever extra annotations you need to add to your program in order to expose that information to the platform in a way that makes sense, that should be handled by the toolchain, basically, in one way or the other.
So I had not this extensive idea, but an idea which is more, it's more like for a specific purpose, which is as like a, that I use this super weird keyboard layout. And the problem with super weird keyboard layouts is that all the programs break and have different, because they look at the keys typed instead of the scan codes, which is like the main problem, really.
Right.
But there's also, I mean, let's. I'm not a Vim bro, but there are many Vim bros out there. So like for a second, let's, if we got in the shoes of the Vim bro has this problem of like, oh, I want all my programs to accept Vim keys as arrow keys, essentially. And well, and also it's like the inverse as well. The reason the Vim bro has to stay with his atrocious key layout is because many programs have a Vim mode and no other mode.
Yeah.
And so they're like, well, if I go with my Vim keys, then at least on like 70% of the programs, I can use Vim keys. I can't use another scheme that is better. Because then I'm down to like 0% of programs supported. So that's a little bit in the direction that you're saying, is basically the way you would do this is you would generate some kind of event types, like move up, move down, move left, move right. And then my idea was like, hey, basically you take the arrow keys, because a lot of things happen on arrow keys. You make them the more abstracted version, and then you allow remapping of those things, and then you just had to be, rule with an iron fist in QA to say, if I see you respond to arrow keys and not these high level things, then you fail QA. You have to use the high level ones so that they're remappable, unless you have good reason to not do that.
Yeah. I mean, it that is one direction. I don't know. I'm trying to. So the way that I try to think about it is like, I try to push it to the point where it's like you wouldn't need QA. Like I want to think of a way, so like sort of in a QA seems like anytime you introduce QA into developing the family of applications on your platform, you're instantly in sort of like a difficult spot, because the whole point of application development is the decentralization part. It's like fundamentally you have this distributed computation problem of like, somebody has to write all these things, somebody has to figure out all of these difficult problems. We can't actually coordinate that. Like that's an uncoordinatable problem. So you run into a big meat grinder problem at the center.
But what's weird about that is at the same time, the again, every historical example of platform tries to be heavy-handed and stop you from doing stuff. That's how like you end up with like, Android thinks it's gonna just we're not gonna like QA make sure the programs work. We're just gonna like have them be in Java because then they'll work, right?
Yeah.
And then
the
when you are writing an application right now, you have good ideas about how to do things much better than the platform creators most of the time. So much time is spent just like fighting the platform to actually do the thing you wanted to do, which is the good thing. And I think this is actually related to the kind of 30 million line problem situation with Serenum, which is, I find that I've adopted as a general principle that the thing that needs to be, you basically have like, if you're buying software, you have this situation of, okay, I am a user, I pay directly for this user experience from this dev team who make my application. And the more stuff that is under their control and not a third party that's unaccountable, the better things work. So kind of the problem with the driver is, like, if you just got to pick which version of the NVIDIA driver you were calling into, then you could test it before you ship it. But the problem you have is that you have to link against a random driver, right?
Yeah, right.
And the same thing on Linux, you have like, the requirement is you have to link against a random set of all these system libs. And some of them do cryptography, for example. And because there are these third-party Linux maintainer people who want to feel important and also want to be able to inject code into your program to change its behavior post hoc. And that just creates a really bad situation. And so a move like this would kind of be that kind of third-party thing, is you're saying, actually, we want the application developer to be less in charge. Because the interesting thing here is, you're correct that most programs are like atrociously terrible, but the good programs that we know of that some of our friends make, the reason there can be like local goodness is because they do everything themselves and they do it the good way.
Right. Yeah, I think it's the classic like centralization problem. Like, centralization is great centralization is great if the centralized design is actually good, but if you screw up the centralized design, now you've propagated those failures literally everywhere. So it's, the stakes are much higher. I agree. So I don't actually think so. I don't think that it's universally a failure. Like, basically what I think happened is, imagine the most stripped down version of a kernel launching user mode programs. There is some bare minimum protocol that would make sense in that context, and where there's literally zero enforcement of like almost anything by the kernel. We're not there. Like, we've gone several layers above that. Some people try to go way, like, as you say, it's like, okay, we've shot off way, like, the platform has decided to be completely heavy-handed in this particular direction. We're not really there either. Like, those seem to fail pretty early, but it does seem like we've layered on certain things, and the CLI is a good example of this, because it has these standardized mechanisms that are dead simple. Every program knows about them. Printf, scanf, like whatever, like all of these standardized mechanisms of going in and out.
Well, so a related point, Did you?
Okay.
No, you didn't get to witness this. So the other day I was on a call with Philip and Judah, and they're making like they have some project to try do a like Linux, Windows, Mac. You can double click it and it runs.
Oh, like the ape format?
The
kind of
ape,
thing,
they're using apes, but they're like, oh,
Yeah.
ape. It's like
Nice.
ape plus Sokol, right? Situation.
Whoa.
And
Alright.
the crazy thing is, I was able to. Oh, well, okay. I downloaded the ape and I had to mark it as executable, and then I had to run it with like an
Right.
LD, because they have a dynamic library. I got an early build, so it was a little bit weird. But the crazy way this thing runs is it like it launches, right? It launches as a shell script because it has to be this weird polyglot thing, right?
Yeah.
So it launches as a bash script that creates an output, like an executable file into my home folder, which is just it's a linker, or no, it's a loader. It's a static elf loader that they then execute into to look back at the original file and run it as an elf file instead, right?
Excellent.
And then they jump back in, and now they're a statically linked elf file, right? But then they need to, but then so now you're running the ape, but what if you want to call into dynamic libraries? Okay, this thing has a dependency on CC to do that, because the way they on a Unix system get the libc is that they emit the most bare bones C program possible into some location. Then they do invoke with they do like system call CC, compile the program.
Whoa.
Okay, so they compile the program. Then they have there's like bin output somewhere, a dynamically linked elf program. Right. That links against the system libc. Okay.
Oh no.
So then they load in the file into some space.
Oh man.
And then go to _start or whatever. Okay. There's a memory location passed in as a string parameter to the program. So basically, the at start runs, which goes into the libc, which does the startup stuff, which then goes to main of the program that they recently output to disk. And then in the string args is a memory address that they pass out with passing, like a quick passing code. And then that's a function pointer to call back into the thing to just like deposit full function pointers for like, here's how you call LD library, like here's you do DL open, and then I think they exit back out, But there's a whole bag of stuff that they're depending on as like layers on top of, and it worked fairly well. Like on Linux, actually, it's a pretty reasonable. Like it works, right? Because on a Linux system, you will have a CC of some form.
Yeah. Well, actually, that's a good example too of like, so that's another example of the act of DL open not being standardized on Linux is actually an example of another place where it's like the platform standardizing more is actually beneficial in a sense. Because on Windows, you don't have to be concerned about things like TLS being undefined by the kernel or by the platform, I should say. Or DL open, for example, like, because these things are just on Linux, thc are defined by glibc,
which arguably is part of the platform.
Yes, at that point, it's like ultimately what happens on Linux is that it's like this chaotic like pile of
you could,
it's like chaotic pile.
You can almost define the problem as like, if you don't define, if your platform like is not big enough, then somebody else will do more platform on top.
Yeah, I think that's, and I would argue that that's the creation of the browser right there. Actually, I think that I think that is totally what's happening there. And so I think that
well, the weird part, my
comes...
conclusion from the crazy thing is like looking at that, it's I thought the native programmers were like different from JavaScript programmers, but actually it's the same. Like this problem of the like is the how can we have the JavaScript thing that runs in Angular and React at the same time? It's exactly that.
Right.
And it's this crazy Jenga tower of bullshit.
Yeah. I think ultimately it's a breakdown of trust, right? It's like I don't trust Microsoft as a platform steward, so I want to basically like I want to ship my application to Windows with a catch. It's like, no, I've abstracted everything, so I can actually also ship to this other thing. And I don't have to be beholden to these people anymore. So I think when there's a breakdown of trust, everything kind of gets worse, because it's like, like everyone has to just abstract over everything all the time, and it feels like nothing gets done. and I think that so I think that the browser's a direct or the prominence of the browser is a direct consequence of that, I would say. Also, like the UI stuff on Windows, like the idea of the command palette not being a standardized thing. UI was standardized on Windows before. Like everything looked and felt the same. Everything was standardized. It wasn't the platform. Like it wasn't that inversion of control flow that I was talking about before. Another good example of that inversion of control flow, by the way, was the Handmade Hero update loop. Like I think that's like the seed that was planted in my brain that got me thinking about this stuff like several years later. But it's like the idea of the platform layer calling update and render and defining the main loop is an example of this like inverted control flow. But anyways, so UI on Windows.
Do you want to just recap that quickly?
Yeah. So basically, like, if people are familiar with like SDL, the library for platform abstraction on Windows or on Windows, Linux, Mac, all the prevalent platforms, Switch, like PlayStation, like all these things. It's a very common game programming library. Lets you open a window, get gamepad input, even has simple graphics and audio output and stuff. Even has networking. Like it has all these like platform abstraction things on it. And the shape of that abstraction is basically like, as the programmer, you still define the entry point. So you basically have an int main or a win main or something like that in your program. Now, technically, there's like a really thin, weird thing that SDL does, I think, where they technically define win main and then call into, but for the most part, the person who's declaring like, this is the structure of the program, it is the application.
Wait. Do they do that? Is the reason because of constraints like, the window must be created on the main thread and therefore...
I'm not sure if that's why. I know on Windows, so I'd have to think it through a little bit. On Windows, there's a lot of weird crap about like applications can be compiled under a particular subsystem.
Mm-hmm.
So as far as I know, there's no way actually to make a executable file that launches correctly from a terminal. Like when you're in cmd.exe, you run the program and it doesn't detach immediately. Like you get standard output in the terminal or whatever. If you want that behavior, you have to build it as a console subsystem, which is a linker argument. Like you have to be able to say, this is the console subsystem. If you do a graphical subsystem, and the problem with shipping graphical programs in this console subsystem is if you launch the program from like Explorer, like you double click the file, then it like opens a terminal and you're like, I don't want this terminal. What is this? So you have to do it as a graphical subsystem. But what that does in cmd.exe is that it immediately detaches and it doesn't behave like any traditional command line program anymore. So it's like really this janky like Windows nonsense. So I'm pretty sure if I had to guess what they were doing in SDL, it'd be like, if you turn on this flag, or maybe it's on by default, they define win main and then they call int main, which is not the real entry point. It's like you say int main, int argc, char star argv or whatever. They actually define the quote unquote real entry point, which is win main, and win main calls into your main. And I'm pretty sure, because I seem to remember like I tried SDL like, I don't know, 15 years ago or something. And it's like, oh, like if you want the terminal to show up, because back then I was only doing printf debugging or whatever.
Yeah.
So it's like, oh, if you want printf to show up, like have the terminal pop up, you have to like define STL like STL no main, or I don't remember like this weird like structure. But anyways, point being, the structure of the STL abstraction is that you control the entry point, and then in order to start doing anything, like opening a window, for example, you have to call STL create window or something like that. And the way they implement that abstraction is like, oh, like on Windows, you call create window. And on Linux, like X11, you call, I can't remember the API, but whatever the X11 create window is. It might literally be make window or create window or something too. I think X create window or something. Anyways, point being, it like implements it that way. It's like, here's the Windows backend, here's the Linux backend, like X11 backend, here's Wayland, here's like all these different backends you can have. The way Handmade Hero was structured was actually that the platform layer, so the implementation of like the backend of the abstraction, is the one who implements the entry point. And it goes, okay, here's the entry point. And it went so far as to define the main loop of the program. So it literally goes, okay, I'm going to start looping and doing an update loop. And then every single tick, I'm going to call into the application. And so what that did for the application is like, the application is now an update function. It's no longer a main function.
Yeah.
It's basically an update function. It is actually this structure where it's like, oh, I'm called repeatedly. I'm not just called once. And so yeah, it's like this inverted control flow basically, where it's like the platform. So if really easy way to think about this is a call stack. So in a debugger, you see a call stack, this function called into this function called into this function. The way the SDL thing worked was like, okay, here's the kernel down here. And it calls into your main function, and you want to start doing some SDL stuff, so you call into SDL. The way Handmade Hero was structured was like, okay, here's the kernel, here's the platform layer implementation, and here's the application. So when I was saying Windows UIs used to be standardized, they really truly were. Like pretty much every program you used felt like a Windows program, but it was kernel, application, Windows API to build UI.
Mm-hmm.
Whereas what I'm saying with the command palette as an example, really I think it should be inverted in a sense where it's like the application doesn't actually really know what's going on other than exposing the information it needs to do. So another good example of this, by the way, is GPUs. Like that's a very successful implementation of this structure. Like when you write shaders, you don't deal with any of the like synchronization crap for like reading texture data and doing all these. I mean, you can obviously at this point they've gotten powerful enough to do that kind of, or they've gotten I guess like general purpose enough to be able to start doing this kind of thing. But generally, when you write a basic shader, it's like it is this inverted control flow. It's like there's a GPU layer that's completely opaque to you. Like it's just a part of the platform. You get called into and you do your little vertex work and then you're done. And as a consequence, the platform can do a bunch of things correctly before the user ever got involved. And that's how Shader Toy, for example, happened. It's like you have thousands of people who don't know complicated GPU low-level programming who are building all these amazing shader demos. And unbeknownst to them, there's all this hard engineering work that happened in order for all that to work. So I think for the command palette, like I think that same model applies to UI. And I think the CLI is a very basic UI that actually implements this just for things like STD in, STD out, STD error. And so I think you could have similar in spirit mechanisms for UI, including the command palette. So yeah, maybe that makes sense.
Well, and so that still kind of feels like, I guess the thing that I find confusing, or I guess just not currently defined in your example, is like who does own the control flow? Because then it sounds like, oh, there's a system lib that runs, so there's like a user space component to the platform.
Yeah. I mean, that's kind of already true on. Well, it's true.
It's true. It's true across the board. I try to so far be like, that's hideous and that's bad. So I try to like push it all out to be
right. Okay.
Like for example, you get to pick your own on Serenum. You manage your own address space. and stuff. But it is weird though, because there is like a little bit of a sneaky platform that comes in, which is, of course, like being fully bare metal and having no standardization like that really sucks. So what ends up happening is the language runtime is a little bit sneaks in, right? As
you can't. So you didn't escape the user mode kernel or the operating system runtime. You just called it something else, basically.
Yes, although it's like, it's like for 300 lines of code or something. It defines this very important thing of like, well, there's a function you can call to allocate address space, and there's no freeing address space, but someone needs to like bump allocate to hand out the addresses.
Oh wow, okay. So yeah, you don't even implement like the virtual alloc style allocator. You're like, no, we're bump allocating the address space too, actually.
Yeah, well, yes, and it also includes one. Well, so okay, it's no there's like the thing that gives you. I'm trying to think. There's like a language. There's like the base Odin base or whatever, and then you include like the platform lib, okay, and then the platform lib will say, here's how you get address space, this bump allocator, and then it also provides an arena implementation that syscall, puts in memory as you call it.
Got it. Okay.
But that's like plug and play with the language arenas.
Okay, got it. Yeah. So I don't know. I'm trying to think of like, does it require a complicated user mode? Because I haven't thought about how to implement this from like an operating system perspective. I don't know that it actually requires that much. Like fundamentally, I think what I'm saying is that you kind of need a more structured version of std out in a sense, and maybe you have to change the shape of like std out should just be like an immediate std out should be immediate mode, and it should be structured such that it includes UI and like high level command descriptions and stuff. And I think once you had that, you can implement a command palette. Like you can implement a generalized command palette for all programs, whether it's operating system defined or not. Who cares at that point? It's like then you just have all the information.
Yeah, I think the way I approach this is like, what would be really good is if there was like, if it was like, I don't know how this thing looks, but whatever the thing is, you could build it as a sort of L2 platform, or like, even if it's the, various parties have to adopt this way of doing something. If that's something, if it's like, the tools exist in this OS kernel design to facilitate this, then that's something you could iterate on over time, and it becomes like non-blocking for deploying everything else. But there's actually a related thing, which is, on Serenum, for security reasons, everything is very, has to be very sandboxed. And one thing I have not gone around to is that for things like open file, you already need those to be handled by the OS. You kind of have to disallow, programs cannot look at the file system. And so opening a file becomes, I ask the window manager to do a file open pop-up that's associated with my window. And then it can go and find files. And then when I receive them, I now have these files, but I don't even know where they are from. Like, I can't say what is the absolute path of this file, because I'm not privileged to know that.
Okay, interesting.
But then you already have like, well, even if the, I press file open, or, I do the command palette open file, even if that part was in the program, what happens immediately afterwards is going to have to be outside of the program.
Right. Interesting. Yeah. Yeah. I guess another way to think about it too is like, if you imagined a different kind of shell where you weren't imagine like it's an Unreal Blueprints editor
Mm.
or something. And literally what you do, I'm not saying this is the right UI, I'm just like saying like from a platform perspective, this is sort of what you'd want. Like in an architectural sense of like, I have a node graph and I've got a file node over here and I want to just plug it into this program. And that program that should be completely unbeknownst to that program. It should just like, here's the data, operate on it, whatever. I think like, even though I'm not sure that's the right UI, although something like it could be, I don't know. But it's like that should be the structure of the problem where it's like each program it's called into with everything it needs to just get going and do the problem that it was meant to solve. It doesn't, because the fundamental problem that I feel like I've been really feeling working on the debugger is that it feels like in order to build a good UI program, you have to solve 1,000 problems that other people have solved. Now, like I happen to think that like I solve them better than I see a lot of other people do it. So I'm just like, I'll just do it. But it feels frustrating because it's like I'm implementing all these things that really feel like they should be platform handled, like things that are completely unrelated to a debugger. It's like, oh, I have to implement tabs and panels and multiple windows and dragging and dropping tabs and like editing panel layouts, and I have to do and like commands and keybinds, and like I have to do all these things, theming. I have to do.
So how much of this do you think is just code reuse? Like in the sense that because everything is such a trash fire garbage dump, you like I'm starting to do this new program, so I have to do everything from there. So, and this relates to one of the things one of my goals or things I would just want to experiment with when doing this. We're doing for work. I'm doing a rewrite of this visualizer program because it started as like an internal tool and then it's turned into something that people like a lot and is publicly consumed. So it actually makes sense to do it seriously.
This is the Rust.
The Rust thing.
Got it.
And I feel like it's the year 2025, right? How we're like 75 years into computing. How do I draw text?
Yeah.
Right. and I asked around, like, when we were in Munich recently, I asked around, and the point is nobody has a good solution to this. Like Josh does like MSDFs, right? Which MSDFs feels like, oh, because I have this Lamborghini of a GPU, I can afford to do MSDFs. And it's this really expensive way to do text rendering, actually. But it kind of solves the problem, except not on iOS because they don't have bilinear filtering on the textures, and so they look a bit bad. So you can't even do MSDFs everywhere you wanted to do MSDFs. But even for like a CPU renderer, I don't think people. I don't know what people do that often. Well, and also my understanding is you call into like direct write or something.
I do, yeah. I call into direct write just to rasterize. I don't use their shaper or anything. What does
the shaper do?
It's basically like taking all of the different basically the rasterized. Well, it's not the rasterized actually. So basically, when you're laying out a bunch of text, you produce a bunch of. Ultimately, what you get are a bunch of glyphs, and these glyphs need to be arranged. And these glyphs don't map one-to-one with code points. They don't map to one-to-one with characters. Like everything is many-to-many in text immediately, and then the shaping engine is the thing where.
Oh, I see. Where you have to combine. Okay, yeah.
You combine these, you lay them out, you do all these things.
Ignore Unicode. Assume like it's a variable width font. It's a Latin text, right? Even for that problem, it's like, okay, how do I draw the text? How do I draw the text at different pixel densities? Where I need to say, put the text here, this big. Give me the best thing you got.
Yep. Yeah, for that. So that's basically what I assume because, eventually it'll get more complicated. I'll probably use Kiba's library for it, but for the shaping part. But for Latin, assuming variable width, it's not that bad. Ultimately, it's like you want good rasterized glyphs. So I call into direct write for that.
Yeah.
I manage like a texture atlas.
It runs the Turing complete language inside the TTF file in order to do hinting and correctly place the pixels.
Like all this nonsense. Like I don't even deal with that, luckily. The hint, like all that is just a nightmare. So I call into direct write, get the glyphs, and then I just draw. Like then I just have a texture atlas and I draw with it using the glyph information. So it rasterizes them and it gives me glyph information. I render on GPU, but the rasterization is on CPU. But I cache everything.
So you cache it, and then you have an atlas, and you have to you spawn in meshes ish.
Yeah, I have like an instance. Well, basically, like all the rectangles in the UI are the same shader.
Oh, I see.
So I just have like, so it's like just like a big instanced renderer for fancy rectangles, where rectangles can be rounded, they can be bordered, or borders, they can be texture sampling. Like I can mix and match these features. So it's like, oh, like I can be like, to draw an A character, it's a rounded rectangle with no border, tinted white if it's white text, and it samples from this part of the texture atlas, and it's just one shader for all of it. So that's how I happen to do it. But it's text rendering in general is like a complete disaster.
So it's pretty unfortunate. So then I wonder. Well, okay, shortly. My plan, the thing I want to do is I'm a big fan of hand authored pixel fonts. So I kind of want like a three strategy thing where it's like, if it's very, very small and I'm cramming in like paragraphs of text on few pixels, I just need to do like now we need to do an emulated effect where it's like, oh, it kind of looks like there is text, but super, 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 super scaled down. So there has to be some color somehow. And it has to not flicker. I haven't really experimented with that yet. There's like the middle zone, which is, this is so small that we want to use our hand authored fonts. And so we basically have to do, depending on the height, we go like look up what do we have that fits. Okay, get the biggest thing that fits, use that, put the text. And then that's a little bit weird, if you have, because some of the fonts, then you'd want to do the layouting. If you have multi-line text, you're doing like the layouting based on the height. But I think that could be okay. And then at some bigger size, you can just presumably you can just use the Beziers directly. Especially when, my understanding is the way the Beziers are defined in these fonts is that you start like from the outside, and then as you move, you basically raycast through, and at transition points you flip from nothing here, you flip from foreground to background as you go. And so my thinking was like, maybe you could do, if you're on a CPU renderer, maybe you could just generate the scan lines directly, like you're already traversing to output the thing. So maybe you traverse and then you like flip. I don't know. But having this three strategy approach. But the point is that, anyway, the more broad point, I guess, is that the fact that this is even a question and it's not just, here's how you do it. I feel like maybe this question of, I feel like I'm starting from nothing when making a GUI program every time, would be better if you could just import the lib that put the text there.
Yeah, I mean, so it would get better, although there's a lot of stuff beyond that too. It depends on the UI a lot. Yeah. But there's a lot of stuff like this where it's like the platform should be handling this. Like, why am I doing window manager things in the debugger? You know what I mean? Like, why am I doing panels and tabs at all? Like, my panels and tabs should just work with all the other panels and tabs on the system.
I disagree. I think it's good to have them.
Okay.
I mean, yeah, I find it to be useful to have two layers. I think it's a I think it'll end up bad. But you're on Windows, right? Versus So I don't know. That it is a valid belief to have that I think is wrong, probably. But it's,
you mean like it makes sense for tabs from the same program to be forced to be together,
just
basically,
because here's a different type of argument for it, which is
Mhm.
if you have, so like Alt tab versus Control tab gives me a 2D field of navigation for tabs.
Right.
Versus if it's all the same tabbing system, then it kind of gets too flattened. I think it gets too big. The great thing about having these several levels is that you can, like, it becomes a nested tree, and therefore it can contain much more things. And then for my case as well, I'm a big workspace enjoyer, so I already have two layers on just my windows. As I flip between windows, and then I flip between workspaces. And then additionally, so in my normal workflow, it might be like, well, I have a workspace, I have focus and a terminal, and I flip between those, and maybe my program that's running. And then inside focus, there's lots of things I switch between, and then I switch between the workspaces.
Yeah. I don't actually disagree with that part. I don't think they should all be tabs, to be clear. Like, I don't think everything should just be a tab. I just think that as the UI programmer for the debugger, I should be concerned with debugger problems and not implementing a window panel tab system.
Okay. But presumably maybe there's a future in which, like, you made something that was not a debugger, but your starting position is like, well, I'm going to take rad debugger and I'm going to rip out everything, all the debugger bits. And I already have this great paneling system.
Yeah. It's arguably not just a debugger now, because it can do so many things. It can already do so much stuff, actually. So it's like, it's already not really just that.
But you get what I mean, though. Like,
but yeah,
it's maybe, I don't know. Like, we have this notion of, oh, the library is good when you've implemented the thing just the way, the raw thing, like 7 times, and on the 8th time you like know the shape of the problem and could construct a library that is useful. Perhaps you just have to do 7 from scratch rad debugger style projects, and then at the end you'll be able to solve this.
Yeah, I mean, I've done a lot of window paneling stuff already. I feel like it's not that hard. I just don't think it should be something that each program does, because File Pilot had to do it as well. I think this hinders the usability thing a lot too, because, like, for example, like, I have to have a file browser in the debugger.
Yeah.
And that's like, why can I not just drag a File Pilot tab, put it next to my source file in the debugger, and just use that for everything? Like, what? It's because our tab systems are incompatible, because we both had to implement them, and there's no way to make them compatible. It's like, I'd have to go sit down with Vyacheslav and be for like 5 hours and be like, okay, how do you want to establish this protocol, and like, how do you want to do all these things? Whereas, like, well, I mean, this is what Windows really is. Like, that's what a window is on Windows, is that it's like, it's the composable block of, like, here's a UI thing that you put. And I think ultimately, like, they just didn't keep up with the UI paradigms as they were moving, because, like, pretty soon everyone wanted, like, obviously you had the tiling window manager stuff, you had tabs, you had, like, all these different things that people wanted, and the base mechanism of like Win32 UI was not rich enough to express that. Even today, like, on modern Windows, they still haven't solved this, even though they've, like, added 30 UI libraries or whatever. But, like, Notepad has tabs, File Explorer has tabs. Can you drag and drop between them? It's like, no, they're completely different tabbing systems. It's like, they're incompatible.
Yeah, you could
the same library.
You could tab windows. I think that's actually not hard to do if you wanted that. I'm not as huge.
I don't think this is a hard problem.
No. I have, like,
I
have on my to-do list to, like, do this as a proof of concept, just, like, in order to, like, just for the mogging aspect, I guess. Like, I don't know, but it's kind of, you could just have tabs, I guess. Then the paradigm, Well, okay, so that's a okay. I was reacting negatively to what you were saying, but if you mean the future is like, I guess, how do you feel about multi-window applications? Because that's
I
another thing that most people do not do it at all. And so I think
yeah.
also, because I think also the interface, the event loop stuff is already super clunky, and then you get to multiple windows
Mhm.
and it's even more clunky. But then again, I haven't
Yeah.
done it that much.
Yeah. I implemented it like on the rad debugger is multi-window. Um uh I don't know what the ideal world looks like necessarily, but the UI benefits you get from multi-window are like definitely worth it in my view. Like it's a thing you want for sure. Um because like what I do, for example, on with the debugger is like if I've got if I've got like like a one source file I want to be viewing or like disassembly or something, and I just kind of want that on the side. Like my monitor layout is like one horizontal, one vertical.
Mm-hmm.
I can just like make a new window and make my vertical one. It's just like, oh, the disassembly view for whatever's going on over
Yeah,
here.
yeah.
And that just makes much more effective use of the space
Yeah,
while I'm
you can
doing it.
you
So
can
it's a
actually
pretty good
use
thing.
two monitors with the same program.
Yeah, exactly. Yeah, it's like what is happening? Like why is this so hard? Yeah.
The question is, because my understanding is, well, so in normal RAD debugger, you have a bunch of panels, and so you have like a window
Mhm.
with panels in it. And so the question is
Yeah.
like, how would it work if all those panels were windows? Right?
You cut out for a sec. What was that?
Oh, so if all the panels, right now you have a window with various
Yep.
panels inside, what would it
Mhm.
mean for those panels to all be like the normal window primitive, and then have the, because tabs is
I'm
easy,
not even
like
sure.
a Google Chrome style tabbing system is easy for
Yeah,
Windows.
yeah, yeah.
I don't know what you do. I guess you, in theory, you should be able to do everything else. I guess you'd have to have like a notion of a window group, maybe.
So the panel structure is a tree. So it's sort of like depends on what you want. Maybe what you'd want is just a tree, and each node, like one tree for the whole thing, and each node defines the layout of its children.
Mm-hmm.
And so at the root node, if you wanted, like, let's say you were using this system to implement like modern Windows, so not like tiling window managers like on Linux, but
Yep.
like floating windows, canvas stuff. You just have a root node that's like occupies the entire screen. It's the root node of the whole monitor or whatever. And it's like, I'm a canvas layout. Like all my children are floating. They define their positions. I'm not going to lay them out in any particular way. And then each one of those, let's say you wanted it to be like a rad debugger style, like or file pilot for that matter,
Yep.
style panel subdivision type thing. That would just be another flag on each node. So it's like, oh, I'm a panel tree, or like I subdivide my space with my children basically equal, like I lay them out in some percentage based way or whatever, on one axis. And that's another flag. And then finally, the third type of flag you could have is like, I lay my children out as tabs within my box. So
Okay.
like, and then
When you
basically
have
then one is
children, do you have
active.
contents? When you have children, do you have contents as well? I'm behind
You
on.
don't.
I've not followed through the UI series, so I'm like behind on the structure.
Oh, so I guess I need clarification on what you mean. You in the panel tree specifically,
So
or
yeah,
what do you mean?
in the panel tree, like what does it mean? The way I'm thinking about it is that only leaves have contents, really, like have true contents, and
Right.
intermediary panels are just sort of frames and have, splitting definitions for how they.
Yeah. Yeah, that is true, at least. With the way I implemented it in the debugger, at least. It's not really part of the UI layer. So the UI library, or the not library, the UI like posts wouldn't tell you anything about this, but how the panels are sketched out in the rad debugger, yeah, you can't have tabs on parent nodes in the panel tree. Like only leaf panels can have tabs. But once you have the whole tree, then each leaf panel can have some set of tabs, including the empty set could have no tabs, in which case it's just like a layout. Like you can drag tabs there and that kind of thing.
But I guess so. So then the question is, is the OS the window primitive? Does the window window primitive just the leaves, or does the user application get to specify intermediary things in the tree, or does it just say like, hey, at start, I can do like a one-shot spawn of a group of tree window things?
Yeah, that's interesting. I don't know. So the red flag in my head about spawning is that it's like not immediate mode. And I think that like that becomes a problem with the better architecture. Because I think like when you talk about like, oh, I'm mutating the panel layout, now you can't run that every frame, or now you can't call into that multiple times because now it's making a stateful change to user state.
So, but the problem is that when you're in, if you want these to like float up into the window manager, then it's window manager state, and you can't just mutate it however you want.
Right.
For like security reasons.
Yeah.
There's even just like you can't really spawn and grab focus. You know this thing like where you start a program and it's being slow. So now you can't use your computer because you type and then it like takes over focus.
Yep.
Yeah.
Yep. Yeah. 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 I don't know. Like, so I don't know exactly what the right architecture is or the right like primitives to expose to the application are. I think that basically though there should be one, like conceivably there should be one person who implements like 100% of the paneling system. Like that should be how that works basically. So it's like, so basically what I'm saying is the platform slices away all the paneling code from all the applications. They still have ways to express what they need, but but there's some layer at which all of the paneling decisions are just sliced and decided upon. And currently on Windows, like the second you want tabs, it's like, okay, forget it. You have to implement this yourself. Like, or on Windows, it's like also the tiling window manager thing isn't there. So it's like, oh, instantaneously, I need to implement one in the debugger for my panels or whatever. Like immediately you just need that out of the gate. And it's like, okay, like lost all composability with the operating system now. And I have to go do a bunch of work to implement it correctly. So
you probably need a lot of
too.
I think you'd need a lot of cathedral design for this, because there is the one with I like having tiling window managers on Linux, but you do get this thing of it works fairly well for certain types of programs. As soon as you have something that opens many windows, it does like it was expecting the Windows UI flow of like I click a button and a pop-up opens in the middle, except like when you do that now you're like moving the layout around on the screen because there's a new window.
Well, you can have floating ones, right? Like with i3, I remember you could have floating ones that pop up.
I know, but then you're banking on like well, with X11 it was different. The applications had more control. I think some of them are flagged as pop-ups. As in the move to Wayland, applications have less control, which is a good thing, but it has the temporary problem of like, oh, the pop-up now gets treated as a normal window. And so like I implemented a Wayland compositor that did things more my way, and you had to like wrestle with programs because they would behave badly. But you get like the pop-up shows up, and because it's a new window, it's the master window, so it gets allocated half the screen space. So and then it's stretched to the half the screen like that. And then like the other window is now like boop up in the corner here alongside the other things.
Yeah.
So I guess you would have to cathedral design this thing to to support the floating thing, to support tabs, to support having a tiling experience where you use the keyboard mostly, to support mouse.
Yep.
To support
Yeah.
programs want to have some opinion about how things are laid out. There's still the unsolved problem of how do you open a new window /tab/base primitive and have that not be disruptive.
Mm-hmm.
Yeah. If you're focused, there's this thing of if I'm focused in one application's window, then it kind of is okay for it to transfer me between its windows. But if I'm focusing somebody else, then it can't do that. But then I'm not super confident in that claim either, because maybe it's bad.
I think it's somewhat true. There has to be a way for there's some amount of state change that an application wants to be able to have, but I mean, the platform's got to define something to sandbox a little bit, because otherwise you are in modern Windows land where it's you could just be interrupted at any moment, basically. Yeah, I don't know.
But and there's this retain versus immediate mode problem to cathedral design around.
Right. Yeah, and to clarify, you understand this, but when I say immediate mode versus retain mode, I'm not talking about the UI API exactly. I mean, that is a part of the problem, but it's not just I don't like the create window API. I'd rather just call do window or whatever. It's it's not just about that. It's that it's ultimately that immediate mode code is much easier to make. It's not right to call it pure functional, but it's sort of it's idempotent in a sense, where it's it's not literally idempotent. That's not the correct term, but there's some property of immediate mode system where it's you run it repeatedly and it's in a stable state. Whereas with a retain mode system, it's constructing things all the time. Or it's there's different code paths. Here's the construction, here's the updating. The updating part is idempotent. Or it's idempotent is the wrong term for this, but it's there's some kind of stable property.
I think it's there. You want to be in the regime where you build derivations, where it's I build a thing that maps A to B continuously, and it does that often, versus I have this super gnarly state machine that I'm moving around. And that's not to bash on state machines. I think normal developers are way too afraid of state machines, actually. Many problems are state machines. You just man up and do the state machine. But you don't want it to be oh, my crazy gnarly super state machine for my whole program and every configuration it can be in.
I think the problem that comes with adding unnecessary state machines to implement a derivation. I think that's ultimately where you get into problems. Because yes, you do need state machines at the top, but then you have this whole. There's mathematically speaking, there's a waterfall of all these derivations you can compute from it. Oh, my game state, and I've got UI, and I've got rendering, and it all flows down. You could write a mathematical function to describe it, but if you implement that really poorly, it's I have 100 state machines, and I have to wrangle them such that they implement the derivations. So it's not just about the API, but it's just about the properties of programs to the operating system. The operating system should be able to call them all the time to have them live update to stuff without having it be this whole charade that everyone has to go through all the time.
Elaborate on what you mean by that.
Well, I mean, a good example would be hot reloading a file or something, or I don't know. I mean, it's hot. Yeah, any kind of thing where it's you're changing the inputs to a program, and you don't want to have to go through the setup and teardown part of that program again in this sort of user managed.
I honestly think that I think that could be done pretty easily. So say we have the unified tab system or whatever. If you have a window manager call to say like, hey, I have this image, but really it's like, I have this thing that I would like to display and push updates to. One way is easier, where it's just a viewer. Then you can have like, oh, window manager has you select which one you want, and then it spawns that as a new program, and then it like is marshalling this data across.
Yeah.
And just pushes updates, and then you could tile that in with your other windows in the cohesive scheme.
Yeah. The other thing, like, too, would be like if you make the window manager / program state world like expressive enough, you can kind of start implementing, like you can start imagining. Let's go back to like the graph viewer or whatever. I'm in my text editor. I select an equation. I want to view it as a graph, and let's say I've got a bunch of those, and I want to select one, and have it pop through the different graphs or whatever. If you imagine like how you'd implement that kind of a program interop type thing, one way you could do it really simply would be to say, okay, I'm going to split screen 2 tabs. As the user, I open 2 panels on my window manager. And I'm like, these are my 2 panels. And here I'm going to say, my text editor, and then let's say it's like a function call. It's like text editor, open paren, the file that I hope to edit or something. And I just like put that in the address bar or whatever.
I'm
not saying this is literally the UI.
but is this in relation to the command palettes? Is you want to be able to like perform the action of Windows menu type thing, do action. You want to perform that locally in tabs. Like I want to be able to apply an action that is perhaps involves multiple programs, it goes across program space, but I'm applying it not in a sort of completely alienated global view, but like in a local region.
Yeah. I don't think so. I used to have that in the debugger, and I actually took it out partly because of just like space constraints. Like it's like, but that context is still there, is the point. So basically I still open it as like a global thing in the debugger.
It's a global thing,
it's just better. But it is scoped, basically. The context is scoped. So yeah. Like
so it's a version of this, you create a new tab and then you open a program in the new tab that you created, for example, as opposed to the other way around.
Yeah, so basically it's like, okay, as the user, I create the 2 tabs, and let's say each one has an address bar. I'm not saying this is the right UI, I'm just saying like address bar to get the information at the right place. Left side, I say text edit the path to my file. And on the right side, I say graphing calculator viewer, parentheses, and what do I pass as my argument? Well, it's like, well, I don't know because it's derived from the cursor and mark position of the text editor. Like, how do I do that? Like the cursor and mark being like the selection. So, because like I said, I want to select a graph, select an equation, select an equation. Why can't you just dot operator it? Why can't you just say graphing calculator parens, left panel, however you refer to the left panel, there's some way to do it. And you say left panel dot cursor dot mark in that file or whatever.
Well, like however you express that. What I was going to say is, the thing you could do is you could say like, open the graphing calculator, and then you specify some like mode of operation it's going to be in. Okay. And then it basically advertises to the window manager somehow that this thing is available. But then you could get to like, I click and I drag and I like, with magic fairy dust, it like highlights one panel and another panel, and then it's like, oh, they're linked, right? And then they both like show a thing to be like, hey, I linked to this other guy, right? And maybe it's so another version of this is like, well, actually, that's an interesting thing. I've been thinking about this is in how do you develop, if you have very standardized interop, like, hey, I want to capture another guy's video, like but it could be more nuanced things like, oh, well, okay, so I don't know. I'm having a hard time coming up with examples, but you can imagine if there are very developed APIs and things you do often, then the window manager can have bespoke support for that thing. But when things are new, again, you need this thing of like window manager must be able to link up to programs with each other without knowing what the thing is that they're doing with each other.
Yeah.
And the thing I had imagined before was a more clunky interface where it's like you call the thing to do opaque communication, and then you just have to pick out of the unsorted list of other people who want to do opaque information. But you do a user action in one program and you do a user action in the other program. And because of that, they're basically the only thing in the list is the thing you just called on the other guy. And so it's easy to connect. That's more clunky, but it like would work probably. This version is nicer of, okay, if it's connected to the panels, then I can do a more magic fairy dust thing. Then the question, I guess, is the link between the panels or between the programs?
Well, I think so. I think that ultimately, so the thing I said, I think solves that actually, because it's both. Like it could be either, where it's like I've got one tab and I want to parameterize this tab by something in the panel, or I want to parameterize it by something in the program. You could imagine the language of the window manager being expressive enough, and really this should probably just be the language of the entire system. Like it's just like the shell language or whatever. Which should probably also just be the systems language, maybe. I don't know. Like there's like you could go down this rabbit hole, but like point is there should be some way to say this panel dot this property, that's the thing I want to use, and that's what I plug in. And basically if like things like settings and things like basic information are stored in a standardized structured way, that basically like the operating system, and I know this because I've implemented it in the debugger. Every single setting in the debugger for any tab is implemented using the same basic like string tree. It's people can think of it as JSON. It's Metadesk, but it's like it's serialized as Metadesk, but it's like a mutable in-memory version of Metadesk when it's actually used for config. But point is, so everyone implements their settings that way. So if I want to store so on my tab, if I want to store something like a cursor position, since if I'm viewing the source, or if I'm implementing the source viewer, what I literally do is take the root node of my view of my tab, and I say, look up the string or look up the string cursor inside of my tree, my local tree, and that's just a setting, even though it's like my cursor state.
Oh,
and
interesting.
And I do the same thing for mark. And so it's stored in a standard way that's exposed to the external system, and anyone else can talk about those properties, and the source viewer doesn't have to know or care. It's just a basic way of saying like, hey, grab the cursor and interpret it as a textual coordinate, like basically. So it does that for the cursor, does that for the mark. That's the selection state, and then it writes it back out at the end of the frame. And as a result, it's like now suddenly, if I wanted to go to a different tab and say, oh, like let me parameterize something based off of the file, the cursor, and the mark of the source viewer, that's like a well-formed expression now. Like I can just say like, oh, graphing calculator, parens, that tab dot cursor, that tab dot mark inside of that tab dot file or expression or whatever. And it works. In fact, I just opened the debugger because I kind of wanted to see if this was already possible. I don't know if it is, but it's there might be some missing pieces, but the point is, when you have these things well defined, it's instantly like, oh, I can define an expression that declares that actually.
Okay. So that is super cool, but the thing you're describing now cannot ever be the OS or platform API, because that's like terrifically insecure if it's like, well, I just, I store many, I by default store many things on my settings that's viewable by everybody else.
Right. Okay, yeah.
So
Yeah.
you
I mean,
you
obviously,
like
yeah, you need the
can't,
permission model to apply here as well.
yeah. But I think there's probably there's some like 40% solution in this direction or something.
Right. Yeah, because it's like, oh, okay, I select my credit card info, and there's a program over here listening for like,
yes.
It's like, yeah. I mean, obviously, like, yeah, like you need to lock it down and sandbox it and all that. But
I think so. What's interesting as well is I feel like the maximal vision. I refer to it as like fairy dust land or whatever, but when it's like, oh, the full system language, and I can do an expression and it refers to other things, right? That's like the total max out there thing, which seems very, it's like it may be possible, but it's got so many moving pieces, right? Versus I feel like there's a thing that's far in that direction, which has this like, maybe you agree or disagree with this, but I feel like when things are dumber, they're easier to Lego brick, and they're easier to like pull off, in that it's less work to build out the full system, and there's like it's easier for other people to show up and successfully interoperate with it if it's a dumber system, or maybe even like, especially if it's got this extensibility of, well, we have this system where there is labeling or identification, so you guys can go build more complicated things, and we can match up people who speak the same complicated thing, and we will just be the marshal in between and facilitate like linking people up who want to talk to each other, for example.
Yeah. Actually, so I agreed initially with your point that this would be horrifically insecure, but I'm pretty sure it wouldn't be, actually. And I have, like, because so for example, currently on an operating system, what we could do is like there's sketchy.exe on one side, and then my web browser with my bank account open on the other side.
Yeah.
Something I could do is select my account number and drag and drop to this sketchy.exe.
Yeah.
That's something I can do.
Well,
currently
he just screen grabs and then sees the thing.
Right.
Or he keyloggers and he sees the thing, or he inserts key inputs into the input stream. Like,
yes. But so I guess what I'm saying is like that's not seen as insecure because the user manually did that. Like the user was literally saying like, I'm choosing to expose this information. The reason why I think this like magic expression, graphing calculator, pulling data out of this other panel thing is actually completely fine is because that's also user directed.
Yes.
Because the application did not say, I'm looking at this other tab and I can just look at any property of any other program on the entire system.
Well,
it didn't actually say that. It said it said I evaluate this expression in the context of my program. That expression was user provided. So
I know,
so
but it goes through you. So this is where you have to be very vigilant. Is you like if it's user input enters the program and then gets converted to user intent that gets expressed back into the operating system, you basically cannot treat it as user input at that point, which is why you have to design something which is okay. Window manager is able to perform these kinds of cross application interactions. Like user intent has to be expressed at the level of the window manager before it enters any program for it to be secure.
Yes,
and then you're fine with user intent can expose the credit card details. Because in fact, you want that because you want to copy the credit card details to the notepad or whatever to save it to a file.
Yeah. Yes. I think that's still true in this system. Just is what I'm saying. Like I don't think you lose that. Because I think the person who's implementing the address bar, just again, it's not literally an address bar.
So the address bar is the window manager. You mean?
Yes. Yes, it's
Yes,
not in the application.
but then you only get this on open. You don't get this in, like, you could not replicate the thing you described of, well, as I move my cursor. I guess you're saying that the thing would have been linked up at the beginning, the cursor with the.
Well, that's kind of why I'm saying you need the immediate mode style program, because really what you want to do is call the program repeatedly with whatever inputs you have. Like, you basically want to say, like, evaluate whatever is in your address bar and do one run of the program and produce a UI, basically. And and then if you change the cursor position, it reruns. Like, it's the immediate mode thing where it's like you've changed all the dependent state, but you recompute it and then you're done. So you don't actually, it's not like, it's not opening the input, it's just always doing.
So in a sense, this is remarkably similar to a browser, but it's like the one step more than a browser, because a browser is like I type in the address bar and I hit enter and it goes to the server. And this is like I type in the address bar and then computation is happening because of that. Interesting.
As literally like a pure, it's like directly downstream of what the string and the address
but
bar
okay
is.
but that means, but the UI is then interactive, so you have this thing of like, I've entered something into the address bar, I've hit enter, and then that has like refreshed a new like iteration of the UI, which is now a like detached but could be torn down and rebuilt, running loop.
I guess I don't know what you mean exactly.
Like what I mean is that so I type into the address bar like asteroids, and then I get asteroids, but then I can play asteroids, right? And it has to not.
Yes.
At that point, it's retained. The asteroids game is retained. It's like evolving over time.
Right.
I go up to the address bar and I type in asteroids, but use this PNG over here. Use this image in this other program as whatever, as the guy, and you hit enter, and then it's like, oh, I regenerated the asteroids game. I relaunched the asteroids game, and so presumably the game resets, but I'm now in a new.
It depends on how.
Yeah,
I think it depends on how the game does state management, because so the way that would work in the debugger, for example, is if I stored a bunch of the game state on the config tree, and even though the config tree in the debugger is like a string tree, like you could just do the same thing with binary. Like, it could just be a binary specification thing where like it's tight and everything. But if you had that for the game, then it just hot reloads like immediately. Like, it would keep the same game state. It like looks up into the config tree and it's like, here's my player position, here's all these things. The only thing that's different is now this input. So when it recomputes, it'll be like, oh, I'm pulling from this PNG instead, and then I draw that or whatever. So you'd actually keep the game state in that case. Now it depends on how the game wants to do state. Like, there is a concept of like stateful things in views in the debugger, because there has to be. It's like one view is like a watch window, and one piece of state on a watch window is like what things you've expanded. That state, that's like going to be reset. Currently, it is reset. Like, if you close the debugger and reopen the debugger, all that state is gone. Like, I just don't serialize it in the config tree. So you can do things like that. You don't have to, though. Like, if I serialized it in the config tree, it would just pop back up next time you, like, even if you changed anything else about the watch window, it would use that same state. So it depends on what the game does. But and honestly, I don't even think you have to hit enter. Like, maybe you should just constantly be reevaluating it. and it's just like, and then it just works.
I think you need to hit enter. But no, this is interesting. I feel you're causing a lot of problems for me, because I'm gonna have to do now for Serenum 2. I'm gonna have to have like a lot of experimenting with this.
Yeah, it's a lot of fun. I think it becomes pretty magic, like, because I just, like I said, I've only implemented the microcosm of this in the debugger, but it's pretty magical, like, once you actually get there, because things just start out magically hooking up, and it's like, oh shoot, like, Like it's pretty cool. And actually you can store config also in the debugger, for example. It doesn't have to just be data. Like, for example, the cursor, like I said, like I said in the source viewer, to find the cursor position, I'd look up into the config tree, grab the, which is just the standardized tree config format, grab the cursor position, interpret it as textual coordinates, all that, and then I write it back out at the end. I do the same thing in the memory viewer. So the memory viewer, I'm like, grab the cursor, that's an address or an offset in the memory viewer. Same thing for the mark in the memory viewer. But like, I didn't have to interpret it as a textual coordinate. I could have just evaluated it as an expression. And so I literally do that in the memory viewer. The thing that describes your cursor position and the mark position are just expressions. And so if you wanted to say, you can already do this right now. If you say like, open the memory viewer, and I want to make my cursor track to wherever the instruction pointer is. So I'm like, okay, I want to open the memory viewer, and my cursor position, you can say rip.
Wow. Okay, yeah.
Is my cursor position, and you could also do it for your mark, or you can also say like, oh, keep my mark at this address, and then if you start stepping, you'll see your selection grow in the memory viewer. Like you can just start doing things like that, and it's pretty cool. So it's kind of like it is pretty magic, but it is like different than like how you implement these things at first, and so it feels weird and it requires a lot of rewriting.
Yeah, I guess there's one important aspect, which is well, I mean, this is not hard to do, it's just something you would have to do, which is, in order, if you're going to make the alien platform, right, you have to have like, there's a way to just create a window primitive and draw to it, so that the person who's like so that when you port rad debugger, you don't have to like redo everything. You can say like, okay, it's a little bit weird, it's like a thing inside of a thing, but that's what we had before and that's what we have now. But now you can make, if you only target this platform, you can embrace the alienness and do the cool new thing.
Yeah. The other thing is like, it's possible to take a retain mode thing like previous UIs, which create windows and do all these things. It's possible to take those and turn them into immediate mode things. Sometimes you have to change the code, but it's like a rephrasing of the API where instead of create window, it's like get me the window for. It's like window from instead of create window. You just say window from what? Well, it's like whatever unique identity corresponds to this create window call. And then you call it every frame, and then it always works. Because then it's like, well, I'm not creating the window anymore. I mean, essentially, I'm saying get me or create, like find or create window, basically, is how the API shifts. But it works. It does. I'm not saying that avoids rewrites exactly, but it could allow things which were relying on the concept of a window handle that the application controlled. It could allow those to translate into this new system, in a sense. So.
How do you handle the difference between so I can create a new Windows tab thing and then spawn something inside of it, presumably also. So the question is, how do you differentiate between a new version of the program versus I have the feeling you want to be spawning things that are running inside of an existing program a lot, but maybe you do that from like, I have focused an existing window and then I can sort of do new window or duplicate that, or do something.
Yeah, so I have like, at least in the debugger, the way it works. So an example of a program running inside of another program in the debugger in this language is, if I'm in the source viewer and I hover an expression, it will evaluate that expression and show me, it'll do a hover evaluation. Now, when I first implemented that, they had that hover evaluation thing had to be a completely different code path than like opening a watch window, for example, because it's like an immediate mode thing for the hover evaluation, where it's like you move your mouse, you want it to just be
Yeah.
jettisoned and closed. Whereas on a watch window, it's like a stateful thing. It's like you open it and then the user has to close it. But problem is that there's an enormous amount of like machinery that goes into building this that you really just want to collapse. Like you want this thing to just work everywhere. So what I did is I collapsed out all the state management stuff onto the same config tree system. So when you open a watch window, it creates a node in the config tree. It's like, here's a watch tab. Here's the root expression I'm evaluating. Here's all the settings, whatever. And then as you add expressions, it's like, here's the expressions. And all I did actually for doing hover evaluation was like, I just had a separate tree, config tree, that's immediate mode, basically. Where if I don't continuously touch these nodes in the config tree, they get jettisoned or they get garbage collected, if you want to think about it that way. So then it's like, okay, hover evaluation, that spawns a watch window, but it's in this transient config tree, which requires these nodes to be repeatedly touched. And the second I stop touching them, they get thrown away. And so it's actually the same thing at that point. It's like the hover evaluation is just a watch window. I parameterize it with a config tree. That config tree is just from the transient one. Whereas in the case of a tab that the user manually creates, that's in a stable, stateful one where things don't get thrown away automatically. So other than that difference, there's no difference. It's the same code.
Okay, so I just had a thought, a rare case of me having a thought, which is the like one of the reasons this kind of interaction perhaps is so unimaginable from the perspective of normal programming is that application launch time takes, a long time, right? Yeah. But if application launch time is reasonable, which is, it takes no time, 0 seconds, because all you had to do was you had to load a binary that presumably you already had. If you do caching, you could already have it. So you're just basically doing a mem copy of not that much data because the executables aren't huge. And then you have to create a virtual address space, and then you go. And then, right. But it's like not, it presumably is within reach to say, hey, I'm going to spawn, like, because you're doing a cheaper thing. The cross program thing would be more expensive if it's like, I hover this thing and it wants to open a previewer for a model viewer, and so it opens it opens like a sub window which you have support for. You have like a sub pop-up window and then a model viewer that is being, like, the exe is launching to view this file or view this memory buffer, and then presumably you don't keep relaunching it, but you like have it there for the duration of, while it's active.
Right.
And then, that's higher latency, but there are so many things. It's good that we're recording this, because being able to do that or not, that's a measurement question. Is you have to go measure, like a bunch of these things are like, okay, we would like to do this thing. This thing requires certain performance characteristics to be good. And so the question is, what is that latency, and how good could the latency be of like launching through an entry point a new executable? Right now on Serenum, I decide I do like, oh, I don't really care that much, so I'm not going to have caching because I think caching is goofy, or like, I don't know, it's weird. So just read it from the SD card every time, and that's fine right now. But if you wanted to do this, then you would cache way harder to say, no, I'm just gonna the fastest possible process launch, essentially.
Yeah. You also don't have to mem copy right either. Like you can map it into the address space of each.
You could map it, right? Yeah, because it's not write, it's read only execute. So
yeah, I guess like you don't map necessarily the file, but you map like the loaded equivalent of the file, like after
my
relocations and all of this.
my executables are that's equivalent.
Okay, nice.
The way well, it's like the first page, the first 4K page is different.
Yeah.
And then afterwards
Okay.
follows the executable, right?
Nice.
And
nice.
it gets loaded at the same byte. Like it gets loaded in the same place as it would be in the file, which is awesome because then you can run like disassemble the file and file offsets
Right.
match loaded program offsets.
Oh, that's so interesting. How do you do like how do you do DLLs at all? Like
well, I don't do it currently. The plan for DLLs is you
okay.
Because DLLs are just there's so much complexity. The plan is look, you just load the file and you get it into your memory space, and then you can switch it to be read-only execute, and then you can't write to it anymore.
Okay, so those won't be fixed offset.
Yes,
like those won't have the same problem.
Yeah, but then you have this problem of like, okay, you, Mr. Debugger, how are you going to debug this thing? And the answer, I think, is okay, we're going to put some kind of identifiable hash-ish blob somewhere in the beginning. Because, also, there's no start address, because the way you start one of these executables is you always just jump to the front.
Okay.
Because that simplifies things. And then, it immediately jumps to somewhere. It does a relative jump to somewhere inside. So it would be like...
So that means the header of the file is a relative jump?
No. There's 4K of bytes before this, which are not mapped in because you want null pointers to not work, right?
Got it. Okay.
But what you would do is you would say like, okay, so we're going to reserve 8 bytes for this like jump to somewhere else. But then after that, we're going to we're just going to put some random bytes that we deterministically generate somehow from the compile to be just this identification. And then you're going to have a PDB or an RDI file or whatever. And you're going to associate. So you as the debugger show up, and instead of, you basically do a query for what are the different regions of memory that are execute, and then you inspect them, and you have to do this matchup of, well, I look at the front, and that has some basically random-ish deterministic bytes that I'm able to associate. So I'm able to figure out which blob is this in my bag of blobs that I know about from debug info. Is the idea.
Where do the blobs come? Like, how do I know about... So the way that it works currently is like, if someone loads a DLL, there's on Windows. On Linux, you get the same information through a more roundabout way. But on Windows, somebody loads a DLL, they call load library. I see that as the debugger. I get notified of that. And I know the path to the DLL. And that allows me to start looking for the PDB for the DLL itself.
Well, so the thing you've got to remember here is because it's a secure thing where you can't just look at the file system. Nobody can just look at the file system. The idea of the path to the DLL doesn't conceptually make sense. So what you would do is you would get a notification the same way you do for load library, but instead this is the child has marked a new range of memory as executable and read only.
Got it.
And then you would basically say like, well, now I have to try figure out what this is with the debug info that I have. The way you get the debug info is not yet specified.
I see. Yeah, because debug info refers to one debug info file corresponds to one binary. So if someone is loading a DLL, that is a completely different debug info file that has nothing to do with the existing debug info I have.
Yes.
But that could be stored in like this came up when I was thinking about like JEI debugging, for example. Like if you wanted to do compile time debugging, how do you do that? If they JIT to native, it's actually the same exact thing. All you do is like when they JIT some code to native, they also have to JIT the debug info.
Yeah.
And that is somehow referred to by the range of code that you've jitted. So you jit the code, and then maybe at the top there's a header that's like, oh, my debug info is here at this address.
Yeah.
And then I can just parse that immediately.
Yeah, I guess what you would do, yeah, because you want to support plugins and stuff. So maybe, you know, you could imagine a situation where it's like, oh, I jit some code and then I mark it as executable. But I also, before I do so, I've pooped out a debug file into some folder that you're watching. And so you see the debug info come out, and then you're able to do the association. But the key is that, like, one of the cool aspects of having people can't just look at the file system is that it just is this constant systemic break on really wild Unix things. Like, you basically cannot have system libraries because there's no, like, there's no DL open and I provide a name of a lib and then you have a resolve path to go find it somehow and it's going to be provided. It's you load the file, which you had to, like, by default, you don't know of any files. So you can't open any files. So by definition, it's going to be one of your files that you provided. And then, or like, it's going to be in the plugins folder. And then you load it and you mark it as executable. So it just becomes way more constrained in this sensible way.
Yeah. Yeah, for sure. Yeah. Yeah, that's cool.
We've been going for like a long time, so I feel like I probably have to sleep. It's the sun is starting to go up now.
Oh no, I'm sorry.
That's okay.
Yeah, I should probably get to bed as well, but yeah, I mean, I think we covered it pretty well, though. I mean, there's tons of stuff that we went through, so
yeah. I will say, maybe in closing, is I'm pretty sure there's like a lot of, the most disappointing thing about doing operating system stuff is you could scour the internet for what are new ideas in how to do operating systems, and nobody has anything. The best you got is Plan 9, which is like, hey, isn't it cool that we can do distributed computing on all these systems? And it's like, yeah, that's cool, but that's not what that's not what the task at hand. That's a different task that didn't materialize really. And you know, but even they, I guess, kind of have, Plan 9 has like kind of a little bit in the direction of like, they're also like super memey about the mouse, that like you have to have a mouse and like you open a window by dragging. Have you seen this?
No, I haven't seen this.
You should go watch a video. I don't know, it's really weird, but they have some weird stuff. But I guess the point is, it's actually really, really dry. Nobody has any new ideas, like, at all, until this video. Now there are some real new ideas expressed by you in this video. So
yeah, well, that's cool. Yeah, I mean, I'm glad to hear they're new. It's kind of surprising to hear they're new because it kind of fell out of just. It didn't even have to be a debugger. I mean, a debugger put me in a situation where I had to do a lot of this like multi-visualizing thing. But I think it fell out of just like a lot of just writing an application from scratch and thinking about, like, I don't know. It ultimately probably was seeded, like I said, from that Handmade Hero thing of like inverting the control flow. Like, what is the platform just automatically doing unbeknownst to the application that's abstract from the platform, rather than this reverse of like, no, the program's calling into these platform APIs. Like that, and then just that seed, and then I had to implement this visualizer system, and I'm like, oh, holy crap! Like, it's
I think it's much more the visualizer system, I would expect. But I think there are a lot of people who have like fairy dust ideas, where like they're a story about how things should be, that with no contact to reality and any kind of actual practical thing that would work, right? Versus you still have some fairy dust things, which may, like, I don't know, I expect your fairy dust to be like maybe possible. If you ditch the security stuff, you probably could do the fairy dust thing.
Yeah, I'm gonna say I think it just works, but you won't know until there's more specifics. Obviously,
Yes,
like
but
you'd have to go and try it.
there's definitely I used to be a big fairy dust pessimist, and now I feel like wait, actually there might be some interesting. So like Hikari, you remember Hikari? Like
Yeah,
in Discord, he and I have like a 2 year or more back and forth where like he goes off. He's like the real visionary in that he has like crazy ideas that are actually bad most of the time. So he goes off into the cave and then he comes back to me and be like, no, you don't understand. Like they're like tabs and windowing, right? And it has to be this way. And then I just sit and I say like, oh no, I don't think that'll work. I don't think. Oh, but this,
yeah.
this is interesting. But I've become much less of a. I don't want to say less of a fairy dust skeptic because I still don't. I'm still. I think that there probably is a thing, which is like there probably is a paradigm leap, which I didn't think there was before. Before I was kind of convinced that having a window was like it kind of in terms of, and like we could have like the good version of that. But I think that you've convinced me that there may be a thing that even like browser web people will be like impressed by. I'm pretty sure.
Yeah, that's cool. Yeah, I mean, I do agree that I have a lot of fairy dust. I think I've put in a lot of work to try to like investigate the fairy dust. Like the fairy dust.
Yeah,
guides
most people do not
work.
investigate. They just like yap about the fairy dust.
Let's keep. Yeah. I mean, I yap about it a lot, but I definitely try. Like I'm a true believer in the fairy dust, so I try to go and check it out. And it leaves me when I try the fairy dust and it totally fails, I see why, and so I adjust my fairy dust model.
Yeah,
there's still plenty of fairy dust. It's like, I used to call it the cloud. Like the cloud is like there's some cloud up here where I'm getting these fuzzy ideas, and it's like my intuition's like, oh, that seems really good, and like I want to go that direction. And then there's this laborious process of like, okay, I've got to concretize this and pull it down.
Yes,
and
you really have to concretize
that doesn't happen all.
Yeah.
Like in this conversation, you heard me. I'm like, I don't know exactly the shape of what this is going to look like, but I know there's some formulation for the system such that this person says this person says this, and all the rest is, as a mathematician would say, trivial.
Well, most of the Serenum design has started out as like cloud. I'm pretty sure there is a way to do this in right, and then you have to iterate it, but it takes years. It's actually really hard to you have to think about these things a lot.
Yep. Yeah.
All right. Well, there we go.
Cool.
2 hours 40 minutes. Good job.
Yep. Nice.